Okay, again, why do I know that this is ratio test scenario? Factorial. Whenever you see factorial, ratio test just about every time. So as long as I can show that the ratio of two consecutive terms as n goes to infinity is less than 1, I can say it converges. This is kind of weird with the n to the n. It's kind of weird, so let's see how that works out. So the limit as n goes to infinity of n plus 1 to the n plus 1 over n plus 1 factorial divided by n to the n factorial. Okay, so it's important here that the n plus 1 terms are on top and then the non-n, just the regular ones in the denominator. Unlike when you're doing the limit comparison test, it didn't matter which one you put in numerator and denominator. So I'm just going to do some flipping and multiplying here. So the limit as n approaches infinity of n plus 1 to the n plus 1 over n plus 1 factorial times n factorial over n to the n. Drop the absolute value bars because everything is positive inside here. I'm going to rewrite these terms here as the lim as approaches infinity of n plus 1 to the n times n plus 1 to the 1. Just broke up this guy into two terms. Times n factorial. My denominator I'm going to rewrite as n plus 1 times n factorial because those two guys are going to cancel. And then over here I have n to the n. So do some light canceling here. Please don't do it real dark so it's easy to see. Those two guys cancel. These two guys cancel. And I'm just left with this thing here. So this is the limit of n plus 1 to the n over n to the n. This I can rewrite as this is the limit as n approaches infinity of n plus 1 to the n times 1 over n to the n. Well, why am I doing that? Because now I'm going to slide this inside here, which this is kind of cool in a nerdy way. 1 over n times n is just 1. 1 over n times 1 is plus 1 over n to the n. This should look like a limit that you've done one too many times. And if you don't remember, I'm going to refresh it for you. I'm going to set this equal to y. I'm going to take the natural log of both sides. I just switch sides if you don't mind here. Limit as n approaches infinity of the ln of 1 plus 1 over n to the n. I'm going to put the n in front here, so the lim as n approaches infinity of n ln of 1 plus 1 over n. I'm going to rewrite, so now if I plug in infinity, I get infinity over here, and this is 1 over infinity, which is 0, which is the ln of 1, which is 0, so infinity times 0 is no bueno. You have to rewrite it, so the limit as n approaches infinity of the ln of 1 plus 1 over n, 1 over n. Hopefully you remember seeing that before. This is now 1 over infinity, which is 0. 1 over infinity, which is 0. The ln of 1 is 0, so I have 0 over 0, which is a L'Hopital's rule candidate. So I get the ln of y. I'm going to lope it. This is going to be 1 over 1 plus 1 over n. The derivative of this is negative 1 over n squared. The derivative of this is negative 1 over n squared. Hopefully we all see that these two cancel. My wife made some peeps, homemade peeps. So I'm left with 1 over 1 plus 1 over n. As n goes to infinity, this is 0. I get the ln of y. This thing is all just equal to 1. Y is equal to e. What's the punchline? Well, the punchline is this problem way back here that we started is e. What does that mean? It's bigger than 1, right? So since this ratio, this limit that we did, is bigger than 1, this is a divergent Ratio test. Woo-wee. That was a lot. Hope you enjoyed it. I did.